Hi, everyone. Thank you very much for the intro, Daria. So, as you said, the project was called Modeling Checkouts Behavior to Support a Retail Store Operation Design. Before I talk to you about the project itself, I would like to introduce the company that developed the project and the retailer where it was conducted. But first, do you hear me well? The sound is okay? I don't. It's okay. All right. So LTP Labs is an analytical-driven management consulting company, and the main strengths of our company is that it combines advanced analytics with business expertise. So we actually have a perfect balance between the technical part, but also the business knowledge of the projects we develop in different companies. Nowadays, at the moment, we are 70 plus consultants, plus an extended network of people from the academical area or even external advisors. And we have developed more than 300 projects in several countries, more than 15. Regarding those projects, they can cover different areas. We here divided it in two main groups. So one more focus in growth that we can relate to marketing and sales. For example, which products should a company be selling, what should be the price, or what is the next best offer for each client, so more related to targeted marketing. And on the other hand, more related to efficiency, so supply chain and operations, like how should your network be designed, or for example, how should you coordinate your inventory with your product flows. This is like the scope of action that can cover all that LTP's work do. In terms of analytical maturity, the projects can range from a set of more descriptive parts, so what has happened in the past, more like related with reporting or big data, to more prescriptive or even transformational analytics that is looking for the future. What should we do in the future, and how can we make change happen? Regarding the retailer where this project was developed, so it was carried out at Sonae MC, that is the leading Portuguese food retailer, so a large network of supermarkets. It has more than 5.4 million euros of turnover, more than 36,000 employees, and more than 1,300 stores. Those stores can be divided in three groups that we needed to represent in this model, so it would actually accurately depict the reality. So we have larger stores that are typically found in shopping malls, so bigger dimension and more intricacies. We have medium stores. That was the original format, and it's the most common supermarket we actually know. And more recently, what we call Continente Bom Dia, there are convenience stores that are mostly found in urban areas or cities downtown, so smaller in size, but also have to provide a nice service to the customers. Regarding the part of the store that this project was aiming, so it was the checkout area. The checkout area is where the last phase of the customer in-store experience occurs, and people can say that it's like the last image that the customer says about the store. So it has a huge impact on the shopping experience. Therefore, it was a main concern for the retailer. Here we have two examples of images. On the left, something that is more conventional in terms of what the checkout is. So a customer and the people assisting. Sorry, are you seeing my screen? I guess not. Okay, sorry. Yeah, are you seeing the screen now? Okay, I think it's okay, sorry. So what I was saying, yeah, exactly the perfect timing for you see the pictures. So on the left, you have the assisted checkout. So you have a customer, and you also have a cashier that is helping you with the checkout process. And for example, in the picture on the right, you can see that you have some technologies that the customer does the process autonomously, so it can does by itself the scanning process, the payment, everything without any assistance from personnel of the store. So what were the challenge here in terms of what we had to tackle during the project? So in the checkout business area, we have here a trade-off between the quality service of the service we provide to the customers, but also the cost part, that it has to be competitive so that the retailers can be sustainable in its operation. And also a state-of-the-art topic that is related to the wide variety of checkout solutions that exist in the market, and the competitiveness of the market. So each retailer wants to, if a new checkout solution appears, want to be on the edge of that invention and be the first, have the first mover advantage of introducing that in its store. So having this into account, the main goal of the project was to determine the ideal number of checkouts of each typology, so between, for example, in assisted and self-checkout in each store, in order that you can both fulfill the demand that you have of customers, but also meet an expected service level, so that can be evaluated by the time customers stay on queue, for example. So you have some requirements to meet, and you want to know the ideal number of checkouts that can meet you those requirements. And after that, since we, aside from new stores that are going to open, you have a whole set of stores that were built like many years ago, and you want to know which ones and prioritize which ones should be on top of the line to be reconfigured by the changes in the market or in demand, that it should be readjusting that configuration of checkouts. Just to go a little deeper in the trade-off between costs and satisfaction. So on the cost side, you have not only fixed costs of equipment and maintenance of the checkout technologies, but you also have operational costs that are related to the cashiers that operate in each one. On the customer satisfaction, that, as I said, can be evaluated by the queue sizes or the average time a customer spends from the beginning of the checkout until he leaves the store. The point here was to find or simulate many scenarios that could give the retailer an idea where it wanted to be positioned in terms of this trade-off that we are talking about between satisfaction and costs. Regarding the checkout process, so here we're going to describe a little bit the process, so you understand what we had to investigate in terms of parameter statistical analysis. So the self-checkout here, the first decision of the customer is about which checkout am I choosing. So between the assisted or the self-checkout, what we call here the checkout choice criteria. Then regarding characteristics of the customer is like, for example, the number of items that the customer has to check out and buy in the store, and also how many customers arrive per unit of time at the checkout area. Then when we initiate the checkout process, we have how much time does the cashier or even the customer itself scanning each one of the items in the machine, and then the payment time. So credit card or money have different times that are required to fulfill the process, and also the exiting time. So customers want to have some time to put their items in a bag so they can carry them. So all of that, all the process was depicted through these parameters. Also, regarding the checkout typologies that have been surging in the recent years, we wanted to ensure that the model was able to represent all of them. So what we actually did was, instead of representing each checkout typology as an agent or an entity itself, it was made from modular entities representing each stage of the process. So for example, in the checkouts, the first typology we're seeing here, we have the conventional process. So we have a queue and then the scanning of the items, and after the payment, all in a singular flow. While in the second one, we have a queue between the scanning part and the payment part. That was a specific typology that the retailer wanted to test before having it in their stores wanted to know if it would improve the satisfaction of the customers and how it would impact the checkout times, to then evaluate if it was a viable solution to introduce. Regarding the model, we here bring some of the components that were actually critical to the success of the project. So on start, the user was able to choose the checkout configuration he wanted to simulate, or even parameterize some scenarios he wanted to test, and then only see the results in the end. So the model would build the paths that the customers had to make according to the configuration the user wanted to simulate. Also, we took advantage of the agent-based components the AnyLogic provides. So we were able to model characteristics that was specific to each one of the agent, and that varied between runs and scenarios we were having. The Java functions were very useful for providing the flexibility we wanted to depict the process that is actually it's easy to describe, but has some details that are a little bit difficult to model. And then each agent had a logical flow inside of it, so we could actually represent the whole process by the sequence of each one of the parts and the paths that both people and items would go along. Then here we wanted to give an impression, why simulation or why AnyLogic here? The AnyLogic, as I said, provided us with a multi-method model that was very useful to depict the process at hand, and also have both a detailed view, like how much time did a customer, an agent in specific, spend in the checkout area, but also has an holistic view of like simulating a year of the operation of the store and see how the KPIs evolved throughout the year. So it has many features of scenario testing, flexibility, and also, as simulation always provides the ability to test in a virtual environment before actually implementing a solution in the physical space. And it was the choice for technology to support this decision making that we had in this project. Just to enlighten you how the simulator worked. So as I described, we had parameters that were associated with the store or with the performance of its checkout typology. For example, the number of checkouts, scanning time, payment time, or the criteria to open a new one. So for example, you have a store that has a large number of checkouts, but they're not always working at every time. So some of them are closed and others are open. What was the criteria to open a new one? Like 3 people in queue, 4 people, etc. Then we had external parameters that were associated with customers. So how many items, how much time, how many arrived to the checkout, or which payment type they choose, what is their preferable payment type. And then at the end, in the holistic view I was talking to you about, so what was the utilization rate of each one of the checkouts in the store, if you had 4, 5, or 6. What was in the satisfaction side, what was the average checkout time that the customers stood in queue or in the whole process, and actually what was the service level we were providing to our customers in terms of some criteria regarding the time they wait to exit the store. So the project culminated in some results. We wanted to divide this in 2 stages. So what are the insights we retrieved or are possible to be retrieved by using this model, and then some key results in this retailer in specific. So in terms of insights, we had, this is not exhaustive, but are actually the most critical ones. So for example, we could, something that sometimes retailers don't know is what's the average queue size. So how many people are in queue at a moment of time? Do this is more critical in the morning or in the afternoon. So we empowered the retailer with a tool to have an estimation of these indicators, like instead of going to the stores to actually see that in reality, they could simulate it in a small period of time. Also, as I said, new checkout typologies are always appearing on the market. We want to understand the potential of each one before implementing them on the stores. Also, when we have to design a new store, we can easily simulate different scenarios to evaluate what should be the first initial configuration of checkouts in that new store. Also, an important factor was the scalability of the model. So it has to be able to run scenarios for a whole set of stores, the various formats we already seen in the beginning of the presentation, for larger stores, smaller stores, and also be able to simulate like a whole year operation, because in retail we have specific times of the year, for example Christmas, where the stress test is critical, and we want to understand how the stores would react in a period of time where it was the peak of customers arriving the stores. Also, finally, just a bunch of scenario explorations. So we wanted to explore unexplored solutions at the time that could be applied in the stores. For example, if I want to have 5 assisted checkouts and 3 self-checkouts, or invert and have a more self-checkout profile in the store. Advancing to the key results. So the main concern of the retailer was with the fixed costs of the operation. So they had a lot of equipment, a lot of maintenance, that because they had, the sense was that they had an excess of checkouts on the stores they had at that moment. So we were able to reduce on the total part like nearly 15% of the cost. That was actually a result of the combination of reducing the assisted checkout typology and improving or enhancing the number of self-checkouts it would have on the stores to like accompany the growth of this technology in the market, and the more predisposition of the people to make the checkouts themselves. Also, related to the insights we were able to provide, we were also able to test how would be the impact of transactions from an assisted checkout to a more self checkout way. So what we made was, what would be the improvement on the service level? So are we reducing the queue sizes and the time that people wait in queue before arriving at the checkout? And also the operational costs, since a self-checkout doesn't need a cashier to be there to operate. So we would also be able to reduce the costs while even incrementing the customer satisfaction, because they would have to wait a little bit less inside. To end, in terms of conclusion, so as I said, this would provide the retailer with an integrated view of the whole process, something that we sometimes can see in action in the store, but have a full picture of the process without a simulation model would be a little bit hard, and also provide greater confidence and support in the decision making for the retailer when he wants to test a new configuration or open a new store. He would have the tool to have greater confidence in that. Also, the easy identification of improvement opportunities, and also test and evaluate new checkout concepts that are emerging in the market. As feature work or possibilities for improvement, we will talk a bit here about greater validation and calibration of the model. So we actually made a lot of field work to assess if the queue sizes the model was telling us were actually happening in reality. We were able to make these tests and validation in a sample of stores. What we would like to do was to widen the scope and actually do that in all stores. It's a pretty difficult and morose job, but it could be actually done. And also a more profound study in like customer behavior or preferences. Do a person who is younger prefer more self-checkout or more technology advanced, or it prefers or continues to prefer an assisted checkout? So more on customer profile, a more profound study on that matter. So it was it. Thank you very much. I can see there's some questions here, so I'll try to answer. So the first question was, what techniques, data did you use to validate this model, considering that the stakeholders didn't know too much about their own system detailed behavior? So as I said, like in the last slide of the presentation, we actually went to the stores and stood there like a whole afternoon, seeing how the process would evolve during time. So when you have like 3 or 4 people in each one of the queues of the checkout that is open, did the retailer open a new one, wait a little bit, and actually gather all that information to transpose it to the model? So we actually made an experience to simulate like 4 hours of a store in our simulation models, and then go to the store and see if the KPIs evolved in the same way. We were very happy that it happened in the sample of stores we did, but it's also a tricky experience to make, and very we needed a lot of work, field work, to actually validate that point. So last question, I think. How do you set the thresholds for deciding dynamic changes in the number of active checkouts? Yeah, so we actually had a lot of discussion here with the retailer, because we had some requisites from it to actually, so they have some requisites in terms of, I have 3 people in the queue, I want to open a new checkout, but then we went to the store and actually saw the behavior, and it didn't quite happen like that. So we had a lot of workshops discussing with them to understand if it was 3 people, 4 people, and actually introduce that as a degree of freedom, so that they could, on the simulation parameterization, stipulate what would be the criteria to open a new checkout once it has a lot of people in the queues. So it was a little bit struggling, but in the end of the project, I think we could actually accurately represent this dynamic of opening new checkout in reality. Okay, last questions. Do you consider the model is replicable in another retailer's reality or context? I think the short answer is yes. So the main challenge here was to construct or build a model in a modular way. So if you go to a new retailer, it will have queues, or it will have scanning, or it will have payment phases, maybe not combined in the same way, but in the individual sense of the module, I think we could represent all types of checkouts typologies through these modules of individual models of the process. Okay, another question here. So what was the main struggle while building this model? We actually talked a little bit about this in the first question. So the validation of the model was critical to have the confidence of the retailer. So it has the confidence that we were actually representing the process accurately, and we had the KPIs evolving the same way. So the field work was necessary, and it was the main struggle here. Also, since we wanted to simulate a lot of stores and 1 year of operation, it was a little bit difficult to make a model that was fast enough to actually achieve that. We had some back and forth in terms of the module techniques we used, but once again, at the end, I think we arrived at a good result. Another question: did you feel your sample included only one brand retail store, or you have included more brands? So as I said, the retailer had different types of checkouts of stores. So largest ones to more convenience stores that have different behaviors in terms of customers and also in terms of the checkout process. So I think that by covering all these formats, I think we covered all the scope of, for example, if you go to another retailer that only has large stores, we would be able to represent the reality in our model. So yes, I think there's not a real fear, because we actually were able to model, build a model that was tested in different scenarios, in different contexts. So I think it would be valid for everyone. So I don't know if there's any more question. If so,
yeah.
I would like to go there.
Yeah, Diogo, thank you. Thank you very much once again for your presentation. The only just last question from my side has also appeared. Would it make sense to include in this model like other store operations to widen the scope of the decision making?
Yes, it was a question that we posed ourselves during the project. So, for example, like include how the people circulate in the corridors or in the aisles of the supermarket to understand if it would influence the decision for the checkout. Since we wanted to make the model fast, to make a lot of scenarios, we left that out of the scope, but it would actually be interesting to include that customer behavior to actually have a greater scope in the decision making. Yeah, it would be like future work if possible.
Okay, thank you very much. Thank you. We're just very happy to have you presenting
thank you.
with us.
Thank you.
Yeah.
Thank you very much.
So,